The slope of a line. The slope of a line can be thought of as the steepness of a line. So oftentimes we will abbreviate the slope with the letter m, and we can measure the slope by comparing the rise over the run. So if we imagine 2 points on a line, when we move from one point to the other point, we are moving vertically a certain distance and horizontally a certain distance. This vertical distance can be measured precisely by subtracting the y coordinates, so y2 minus y1, and that is what we call the rise. And the horizontal distance can be measured precisely by subtracting the x coordinates, x2 minus x1, and that's what we refer to as the run. So the algebraic formula is y2 minus y1 divided by x2 minus x1, but intuitively speaking, the slope is simply the rise compared to the run. Now, as a more general classification, if you have a line which is sloping downward, so as you look at the graph from left to right, you can see the line is moving downward. This will have a negative slope. Any line that is flat will have zero slope, or we can say the slope equals 0. And any line that is rising will have a positive slope. So for our first example, let's find the slope of the line given by the equation y equals 2x minus 3. So one way to do this would simply be to graph the line. Now you can see here we already have the graph, but this is not difficult. All we would need to do is get a couple of points on the line, and I'll use the ones that they used here. So if I pick x equals 2, y is going to be 2 times 2 minus 3, which is equal to 1. And if x is equal to 4, y will be equal to 2 times 4 minus 3, which is equal to 5. And you can see those points right here. Here's the point 2, 1. Here is the point 4, 5. And the line going through those 2 points is here. So if we remember, the slope is the rise over the run. All we need to do here is count the vertical change. So when we move from this point up to this point, the vertical change on the y-axis here is from 1 to 5. So that is a vertical change of 4 units. And the horizontal change, we're moving from x equals 2 to x equals 4. That change there can be measured to be 2 units. So the rise is 4, the run is 2, therefore the slope is 4 divided by 2, which is equal to 2. Now, another thing about this slope, when we say 4 divided by 2 is equal to 2, keep in mind that it's the same as 2 over 1. And so you can reduce the slope, and you can think of the rise as being 2 and the run as being 1. And what that means is that if you're at any point on the line, for example, if you're at this point right here, to get to another point on the line, you only need to rise up 2 and run to the right 1. And you can see that if you do that, if you rise up 2 here and to the right 1, that will give you another point on the line. So you can talk about the slope in its non-reduced form, or you can talk about it in its reduced form. Remember though, anytime the slope is a whole number, you can always put the number 1 underneath it. Next, let's find the slope of the line that goes through the 2 points, -2, -3, and -5, +1. Now, notice this time they don't give you the equation of the line, but they do give you 2 points. And so one way to find this slope would be to graph these 2 points. So here is the point -2, -3. And here is the point -5, +1. And you can see the line going through those 2 points here. Now, what is the rise and the run? Well, the rise can be thought of as either +4 or -4. It depends on which way you go. Now, in this illustration here, you can see that they are taking this point and they are running to the left 3 units, and so that's why they're calling the run -3. And then they are rising up 4 units, which is why the rise is +4. So if we define the slope using those measurements, the rise divided by the run is going to be 4 divided by -3, which of course can be changed to -4/3. But we also could have described the slope by moving in the other direction. So if we start at this point, we're going to go to the right 3 units, and then we're going to go down 4 units. So to the right 3 would be +3, and down 4 would be -4. And in that case, the slope, which is still defined to be the rise divided by the run, would be -4 divided by +3, which of course is the same as what we got up here. So it doesn't matter which way you move to get from one point to the other, your slope will be the same. You just have to be consistent with how you describe the rise and run. So when you're moving, anything to the left is negative, anything to the right is positive, anything up is positive, and anything down is measured as a negative. Now, another way to measure the slope would be to actually use the slope formula, which simply says subtract the y values divided by subtract the x values, and make sure you subtract in the same order. So the best way to do this, in my opinion, is to take both of your points and write them down where one point is above the other point. Okay, so I'm just going to write -2, -3, and then -5, +1. Now keep in mind, these are your x values here, and these are your y values here. So when I go to compute the slope using the formula, I'm simply going to start at y2. Now which one is y2? Is it this one or is it this one? It doesn't matter. Okay, it does not matter which one you call y2. Let me call this one y2. So I'm going to start with -3, that's y2, minus, and then I have to subtract y1. Well, if I say this is y2, then this one has to be y1. So -3 minus 1. And now the important part is if I chose to subtract in this order, I have to choose to subtract the x values in the same order. So in other words, if this is y2, this has to be x2. And so x2 is going to be -2 minus x1 here would be -5. And now I just need to do the calculation. So on top we have -3 minus 1. These parentheses right here aren't really doing anything. So that's -4. And now in the bottom we have -2, and then minus becomes a plus. And so we end up getting -4 divided by -2 plus 5, which is 3. And of course, this is the same answer we got a minute ago. Next, let's find the slope of the line containing the following points. And this time I'm just going to go ahead and use the formula. So we know the slope is y2 minus y1 divided by x2 minus x1. And let me go ahead and write down my 2 points here. And again, I'm just going to subtract in this order. So y2 minus y1 would be -1 minus 4. And in the bottom, we're going to subtract the x values in the same order, which is 3 minus 3. Now, if you do the math on this, you get -5 divided by 0. And this, of course, is undefined. Okay, we are not allowed to divide by 0. And so this slope is undefined, or you can also say this line has no slope. Now, that's very different from a line that has 0 slope. Remember, 0 slope, or in other words, if the slope is equal to 0, that's going to be a line that is flat. This line here is vertical, okay? A vertical line has no slope. And a way to think about this is that this line is infinitely steep, right? Whereas this line is completely flat. So 0 slope and no slope are two completely different things. Next, let's talk about parallel and perpendicular lines. If two lines are parallel to each other, their slopes are the same. So if line 1 is parallel to line 2, the slope of line 1 will be equal to the slope of line 2. Now, I don't have an illustration for that, but it's pretty straightforward. Imagine I have a line here, which we'll call line 1, and then another line, line 2, is parallel to that line. So here's line 2. It's pretty clear that these two lines have the same steepness, so they have the same slope. Okay, so that's what's going on in this situation. Now, what does it mean for line 1 to be perpendicular to line 2? Well, if my line 1, let's say, is right here, to be perpendicular, not only does the second line have to intersect the first line, it has to intersect it at a 90-degree angle. So if you imagine here the slope of this first line, let's say it's equal to positive 2/3, which you can see right here. If you rotate this line 90 degrees, that little triangle is going to get rotated as well. So what happens is the run becomes the rise, and the rise becomes the run. But also we can see very clearly one line has a positive slope and the other line has a negative slope. So if two lines are perpendicular, the product of those two slopes will always be equal to -1. But we can also say the slope of the first line is the negative reciprocal of the slope of the second line. And I find it to be a little bit better if we define it in this way. So if line 1 is perpendicular to line 2, if the slope of the first line is A over B, then the slope of the second line will be -B over A. In our next example, we have a chart which shows you the price of gas every 5 years in the United States. So here you can see in 1955, the price of gas was 29 cents. And this point over here tells you in 2005, the gas price was $2.93. What we want to do is find the slope of the line connecting those 2 points. So if you imagine a line going through those 2 points, we just want to find the slope of that line. And then we'll explain the significance of the result. So first, let's talk about in 1955, what does the point look like there? Well, on the x-axis, you have the year, which is 1955. And on the y-axis, you have the price of gas, which we're going to do in dollars. And so 29 cents is $0.29. And in 2005, we have this point over here, which corresponds to the year 2005 and a gas price of $2.93. So the slope of the line going through these 2 points, I'm going to subtract, and in this case, I'm going to subtract the other way just to show you that it doesn't matter which way you subtract. So I'm going to take 2.93 minus 0.29. And on the bottom, 2005 minus 1955. And so that bottom number is 50. And the top number, $2.93 minus 29 cents, is going to be $2.64. So now if we divide 2.64 divided by 50, that's going to give us 0.0128. Excuse me, 0.0528. And what does this mean? Well, remember, in the top here we have dollars, and in the bottom we have years. And so what this means is it's about a 5-cent increase per year, right? So the slope of this line represents how fast the price of gas is changing per year. Okay, so it's about 5 cents per year. And a final way to interpret this result is to think that this is the average rate of increase of the gas price per year. Because you can see very clearly in some periods on this graph, the increase was much faster, right? So you can see the slope of this line here. So for example, from 1975 to 1980, the price of gas went up very steeply. But then there were other periods where the price did not increase as fast. For example, from 1990 to 1995, the price increased very little. So this represents the average rate of increase over that period of time. We can also use the slope of a line to find the speed of a moving object. So in this example, a car is traveling at a constant speed. The graph of the distance of the car, so this is distance here, has traveled over a period of time in hours down here is shown on this graph. Use the graph to find the speed of the car. So all I need to do is pick 2 points on the graph. You can pick any 2 points. The easiest points to choose would be this point here, which says after 6 hours, we have traveled 360 miles. And this point down here, which says after 0 hours, we have traveled 0 miles. And the slope is simply going to be the y-coordinate, 360, minus the y-coordinate, which is 0, divided by 6 minus 0. So again, I'm just subtracting the y-coordinate here minus the y-coordinate here, and the x-coordinate here minus the x-coordinate here. And this, of course, is equal to 60. Now let's keep in mind that on top we had miles, and in the bottom here we had hours. And so this is going to be miles per hour. And so this is a measure of the average speed over that period of time. Now in this case, it is the speed because they tell us that the car is traveling at a constant speed, meaning that it's never speeding up or slowing down. In our next example, a patient tells her doctor that she is experiencing hypoglycemia during her workouts at the gym. Her doctor gives her a blood testing kit and has her repeat her workout, monitoring her blood sugar level every 5 minutes and noting any symptoms that she is experiencing. The results are shown here. Okay, so you can see that she starts out with a blood sugar of 100, and after a few minutes, the blood sugar increases up to a little bit above 120, and then it begins to fall off here. So it begins to decrease, and then it levels off down here at the bottom. So the points on this graph represent the blood sugar level at that particular time. But if you look at 2 points on the graph, you can see that there is a slope involved which describes the rate of decrease of her blood sugar. So we can answer questions about this. Like I can say something like, when is her blood sugar decreasing the fastest? Well, it would look like from here to here is when the blood sugar drops the fastest. It drops about 40 points in 10 minutes. Whereas you can see in the next 10 minutes from here to here, the blood sugar does not drop as much. So the slope will tell us the rate at which that blood sugar level is dropping, whereas points on the curve simply tell you what the level is at a given period of time, or at a given time. Next, we're going to talk about difference quotients. One thing that I can say right away is a difference quotient might sound kind of complicated. It isn't. The difference quotient is just another way to measure the slope of a line. But in this case, what we have is some kind of a function represented by this graph here. So this is y equals f of x. And if I pick 2 points on that graph, points P and Q, I can draw a line through those 2 points. And this is called the secant line. And then we can find the slope of this line by simply using the formula slope equals rise divided by run. Now, if you'll notice on the x-axis, point P corresponds to x equals a, point Q corresponds to an x value of x. So point Q has an x value of x and a y value of f of x, and point P has a x value of a and a y value of f of a. So if I find the slope through these 2 points, we are going to subtract the y values divided by, and then we're going to subtract the x values. And this is simply the slope of the line that goes through P and Q. Now, this formula right here is what we often call the difference quotient, okay? So when you have a function and you draw a line through 2 points, the slope of that line is called the difference quotient, and this is the formula for computing that. So for example, if f of x is equal to 3x minus 5, we want to find the difference quotient f of x minus f of a divided by x minus a. So first of all, let's note that f of x is 3x minus 5. That was given to us. F of a is simply 3a minus 5. And so this difference quotient, f of x minus f of a, divided by x minus a, is simply 3x minus 5 minus 3a minus 5 divided by x minus a. Right? So again, I'm just taking 3x minus 5 and putting it in here, 3a minus 5, putting that in there, and performing the subtraction. So if we do the math here, this becomes 3x minus 5 minus 3a 5, all divided by x minus a. And now we just want to simplify, so notice that negative 5 and positive 5 cancel out. So we have 3x minus 3a divided by x minus a. In the numerator, you can factor out a 3. And this is very nice because now we can see that the x minus a cancels out, and we get 3. So the difference quotient for this particular function is 3. Now this shouldn't surprise us because if you graph this function, this would just be a line, right? And we know that a line has a constant slope. And since the difference quotient is just the slope of a line drawn through 2 points on the graph, it's not surprising that the slope here is 3. For the next example, we have a slightly more complicated function. We have f of x is equal to x squared minus 4. So if that's true, of course, f of a is simply a squared minus 4. And so f of x minus f of a divided by x minus a is going to be x squared minus 4 minus the quantity a minus 4 divided by x minus a. Again, we can distribute the negative here, so we get negative a squared plus 4. And then notice that the negative 4 and positive 4 cancel out. So we end up with x squared minus a squared divided by x minus a. And now to simplify, x squared minus a squared can be factored using the difference of two squares formula. And then once again, we can cancel these out here, and our final answer is x plus a. Now, why is our answer here a variable, whereas in the previous problem, our answer was a number? Well, it's because of the nature of the graph. So x squared minus 4, if you were to graph it, would look like this. So now if you pick 2 points on that graph, let's say I pick this point here and this point here, the slope of the line that goes through those 2 points will be very different than the slope of the line that goes through a couple of other points. So notice that these 2 lines that I'm drawing here have different slopes. So the slopes of these lines are going to depend on the x value and the a value. Now remember, the x value is just the x coordinate of the second point, and the a value is the x value of the first point. Now there is an alternative difference quotient formula. It's the same thing, but it's going to look a little bit different. So once again, imagine we have a function f of x, and we have 2 points on that function. We're going to say now that the first point occurs at x, and the second point occurs at x plus some amount that we call h. So h is just the distance between these two things here. So if I want to find the slope of the line through these 2 points, we're just going to subtract the y values and divide it by the subtraction of the x values. So point Q has coordinates x plus h, f of x, and point P has coordinates x, f of x. And so the difference quotient is going to be f of x plus h minus f of x. So again, just subtracting the y values here, and then divided by x plus h minus x. And these x's here cancel out, and you end up getting f of x plus h minus f of x all divided by h. And this is the alternative difference quotient formula, which you see right here. So now we will redo the previous 2 examples using this other formula. All right, so to compute the difference quotient here, we have to do f of x plus h. So in this particular example, f of x is 3x minus 5. So f of x plus h is going to be 3 times x plus h minus 5. And let me go ahead and multiply this out. This is 3x plus 3h minus 5. So when I go to compute the difference quotient, which has the formula f of x plus h minus f of x all divided by h, f of x plus h is this quantity. And we're going to subtract f of x. Now f of x is just the original function. So make sure you put that in parentheses. And in the bottom, we just have h. So one thing we really like about this formula is the denominator is simpler. Let's go ahead and remove the parentheses. We have 3x plus 3h minus 5 minus 3x 5 all divided by h. Notice that we can cancel out 3x minus 3x, negative 5 plus 5, and we end up with 3h divided by h, which is 3. And that is the same answer we got a minute ago. Now for the second one, same idea. To find the difference quotient using this formula, we're going to need f of x plus h, which in this case, since the function is x squared minus 4, that's going to be x plus h quantity squared minus 4. If you multiply this out, that's x plus h times x plus h minus 4. Continuing with the multiplication, skipping some of the details here, you end up getting that quantity. And so f of x plus h minus f of x all divided by h is going to be this quantity here minus f of x, which is going to be minus the original function. Make sure you put that in parentheses, and then all divided by h. So next we'll go ahead and distribute the negative here, which gives us this. And now we look to cancel. So let's see, we have an x squared minus x squared, a negative 4 and a positive 4. So all we have left on top is 2x h plus h squared divided by h. And if I factor out an h, that's going to be h times 2x plus h, all divided by h. And if we cancel those out, we get 2x plus h. Okay, now that looks very different from the answer we got a minute ago. And it's because we're using a slightly different formula. So if you remember a minute ago, we did f of x minus f of a divided by x minus a. And what you got there was x plus a. Okay, but are they the same or are they different? Well, let's think about it. So remember in the first example, this one, we said that the first point was at A and the second point was at X. And in the second one, A was X and the second point was X plus H. So if you take this formula here and you replace X with X plus H plus, and then you replace A with X, notice that you get 2X plus H. So you get the same thing, all right? So how can there be two different answers for the same thing? Well, it's because, again, the difference quotient has two formats. So normally what we do when we're asking you to find a difference quotient is we will specify which formula we want you to use. So either this formula here or this formula here. So once we specify that, there's one unique answer. And that concludes this video lesson.